Okay, so today's Leetcode daily challenges construct a string with repeat limit. I have solved this, so I'll first walk through the problem statement and then the examples and then the solution, of course. So the problem statement states that we have been given a string and there is one number given, like one integer given 3. What we have to do is we have to create or basically return another string which which does not repeat the same character more than 3 number of times. Okay, so for this example the limit is 3, so none of these characters in the resultant string should repeat more than 3 times. Okay, but how do we need to construct the string? It has to be the lexicographically largest string. Now I'll tell you what does this mean. Okay, first let's go through this second example so you will better understand lexicographically larger. So we have AABA. Wait, we have AABABAB, BABAB, AABAB. Okay. So what we have to do is we have to construct a string with repeat limit 2. Okay. And lexicographically larger means that suppose if we have two strings, suppose we have two strings. Okay, this is only for example. Suppose we have a string A, B, C, and we have a string A, B, B. It is saying that in the first position where A and B differ, string A has a letter that appears later in the alphabet. Later in the alphabet means a larger letter. So suppose between A and Z comes later. So Z is a larger alphabet. So if string A has that letter, then that one is larger. So these two are same. Now for these two strings, if I consider them two different strings, 1 and 2, this one is lexicographically bigger because between A they are same, B they are same, but between C and B it is having a character which is lexicographically bigger. Okay, so this is the explanation, but let's go through the problem statement as well. So what they are trying to say is, suppose we have CC ZA ZCC C Z A Z C C. Now, just to understand, suppose for example, you think that the resultant string is A C C C Z Z C. Now, I am not writing C 4 times because for this problem statement, the repeat interval given is P. Okay, and if you think like suppose for just example think that you think this is the correct answer, there is another approach where the larger alphabets are coming at the beginning. Okay, now only if you compare this part you will understand that this string is lexicographically bigger because it is saying that the first position where these two strings differ, this is the first position, this is the 0th index where these two strings are differing. This string has A and this string has Z, and the string which has a letter that appears later will be lexicographically larger. So here Z is coming later, so this string is larger. Now let's check. Yeah, okay. So I think that is pretty much clear. Okay. So I won't stress on that lexicographically larger any longer. That should be sufficient. Now, how am I proceeding the solution? Okay. Hmm. Okay, so what my intuition is that I always need the largest characters first. Okay, largest, I mean, Z is the largest, right? So A is smaller and Z being the largest. So I always need the largest characters, largest letters together. Like I have Z. So first I can take a count of how many characters I have, or basically like a frequency map. So I have 2Z, I have 4C, and I have 1A. Okay. So what I want is that all my Z stay together until k number of times. Okay. That is the problem constraint. That until k number of times I can have Z together. So what I'll do is I have 2Z and K is 3. So it allows me to have Z twice. So I can give Z twice. Okay. Now Z is done. Now I want C to be together because that is the next largest, but it can be only together for K number of times. Okay. I have 4 C's, but I can only pick 3 C's. So I pick 3 C's. Now, here I cannot pick C. I have a C. I still have one C left, but I cannot pick it. What I have to do is I will have to pick the next largest character only once. Okay, now I suppose if I had two A's, that doesn't mean I have to pick both the A's together. Okay, I'll also explain that, but I only need A once, right? And then I have to continue on my C. If I had like six C's, I could have given C thrice here. Okay, here I have only four C's, so I'm only giving one C. I still have one A left. Like if we think I had two A's, then I can give one A here. Okay. Now why suppose if I had two A's, uh, why I should not give both the A's together? Because suppose if I give both the A's together and I give a C letter, okay, now, if I compare this to this string where I am telling you that we can only have A once, yes. Now, if you compare, which one is lexicographically larger between these two? This is the first place where both of the strings differ, and this one is having the larger alphabet. This is the reason we only have to pick the next largest character but once. Okay. Now, let's do one thing. I'll explain you my code's intuition and we can also do a dry run. So my intuition is I'm using a max heap, max heap, which is holding character and its integer is basically the frequency. To calculate the frequency, I am using a unordered map. Okay, so basically this unordered map will return me something like A is there four times, B is there two times, oh sorry, three times. So here I'm taking this example. We have already talked a lot about this example. So yeah, A is four times and B is three times. Okay, and in priority queue, get I'll get B at the top. Okay, because that's how it is. It is a max heap. I'll get B at the top along with its count, which is 3, and then I'll get A along with its count, which is 4. Okay, this is the resultant string. I'm checking if like until this priority queue is empty. Not necessarily. See, we don't have to use all the elements. So I'm also giving one return statement here. Okay, so we might break before, like we still might have some elements left in our priority queue, but we will break before that. Okay, let's see how it goes. So the count. So this is the largest character. I have B. Its count is 3. Okay, so I have 3. Temp is 0. Okay. Now count is not equal to 0 and temp is not equal to 0. Basically, I can only pick something at max k number of times. Okay. But it should exist at least k number of times. That is why this condition is there. Okay. Now here in answer, I am appending this character B. Okay. So I've started appending. Now the count reduces to 2 okay, because I have used b once, I can only use it two more times. And my temp variable, which I'm using to calculate if I do not exceed k number of times, so this increases to 1 because I've already used it once. Now, temp is equal to k, so we won't enter the loop. Now, again, I append b, my count decreases to 1, this variable increases to 2. Here, k is 2, okay, by I actually changed the repeat limit to k, so k is 2. So now this matches, and count not equal to 0 means that I still have b left. I still have b left. Okay, how many b's I have left? I have one b left, but I've reached the limit. Okay, I cannot give another b. So what I'm doing is I'm resetting the counter. Okay, like once I've reached the limit, I can reset the counter. Now see here, what I'm trying to do is I want the second largest element, right? Or basically not the next largest element. So in a priority queue, I cannot access the second largest element. So this is kind of a hack, you can say. What I'm doing is I'm picking up the current element and storing it. Like I'm popping it out, but storing it in a variable only to push it later. Okay, so this is so what this will do. This is will like remove the largest element, and for the time being, I can access the second largest element as the top. Okay, so this is just a check if priority is not empty and I'm able to access the second largest character. I also pick the second largest count. I've reduced its count by 1 because of course I'm using a. Now when I use a, its count will reduce to 3, right? I'm using, there are 4 a's I've used once, so I need to reduce the count. In answer, I am adding the second largest. So it was bb, now it is a as well. Now the second largest character is it's still left. See, suppose if I only had one a, okay, I don't need to push it back again, right? Because I've used it. But if I had a twice, so I have to push it back again, right? That is why I'm pushing it back again. Other than that, this this basically means suppose if I don't have any next largest character left, okay. So in this scenario, what happens? We see we are not using all the A's. We are only using three A's. Why? Because we have used A twice. Now I cannot add another A here, and I do not have a next largest character. We have already used all the characters. So in that scenario, we have to return the answer. We don't need to use all the characters. Okay. And yeah, I'm just pushing the current which I had removed for my hack. Okay. And yeah, so we'll simply be able to get this. And if you want, you can try run the first example as well. Yeah, you can try run the first example as well, but this solution will work.